You're to find the directional derivative of the function of xy equals x plus y squared at the point 4, 0 in the direction of the vector u equals half I plus the cube root of 3 over 2 j. Alright, so directional derivative. Remember, when you find the derivative, it means you differentiate. So you're going to differentiate the function. Directional means in the direction. The direction, when it comes to vectors, are I in the x direction, j in the y direction, k in the z direction. Alright? So here, remember the way you write this thing? It's the directional derivative of the function, but in the direction of u. So this is traditionally how it's written. Now it's going to be when you differentiate the function and assign directions to it. So that's the gradient vector of f. You multiply it by the vector, but remember now, you must use the unit vector. You multiply a function by a vector by the unit vector, you get back the same vector, the value of it at least, although it might look different. Just like how if you have a number 5, if you multiply 5 by 6 you get 30, right? But you want back the value of 5, so what do? You multiply 5 by the unit number 1 to get 5. But remember now it's 6 you had a while ago. So if you have 6 divided by the value of 6 is the same as 5 by 1, which is 6. So 5, any number by the unit number give you, my, what did I put 6 here? It's 5. So a number times the unit number gives you back that the value of that number. So a vector, remember the grad f is going to be a vector times the unit vector will give you a value equal to that original vector. The unit vector, u is the vector, but you put a hat on it to show that it's a vector. So it's going to be the grad of f times the vector divided by the magnitude of the vector to give the unit vector, right? Now this function is a scalar. You'll find the gradient of that scalar. Remember now, the grad f is going to be partial derivative of f with respect to x in the direction x, which is I, plus partial derivative of f with respect to y in the direction of y, which is j. Well, we don't have any z here, so at least we have less work to do. Right, we don't have to be working on a z. Now, here. Oh, by the way, you pause the video and finish it off for me. Write it down and finish it off. I'm waiting. Okay, so you're finished. Alright, so let's see what happens here. What is partial f by partial x? Well, when you differentiate this, you get 1. Right? And then, what is partial f by partial y? You differentiate with respect to y, you get 2y. So what you have, oh, we should write Nabla f here, the upside down triangle. Remember, that's what they call Nabla. Sometimes they call it del. Alright, so Nabla f in this case is going to be 1i I just write I and not bother to write the 1 plus 2yj. Nice. Now finding the unit vector now. U with the hat on it. Alright. So the magnitude of u. What is magnitude of u? Remember this u business here. It means half. The length of this line is half in the I direction, and then in the j direction, positive j direction, the height of this is square root of 3 over 2. Right? So u, the magnitude of u would be the hypotenuse. This would be a right angle. So use Pythagoras theorem. So u is going to be the square root of half squared plus square root of 3 over 2 squared. So it's half squared plus square root of 3 over 2 squared. Which is what? The square root of half squared is what? A quarter. Plus square root of 3 over 2 squared. If you square the top, square root of 3 squared is 3 over 2 squared is 4. Oh, so it's a quarter plus 3 quarter. What is 4 quarter? So the square root of 4 quarter is the same as square root of 1, which is 1. Make our work easier because it's 1. Right? So the magnitude of it is 1. So it so happens that the unit vector is the vector itself, because if you divide anything by 1, you get back this same thing itself. So directional derivative of f is really the dot product of the grad of f and the unit vector. In this case, it is I plus 2yj dot, let me see if I can remember, is half I plus square root of 3 over 2j. Alright, let's see. Half I plus square root of 3 over 2j. Good. So remember now, when you dot two vectors, is what is direction times direction plus direction times direction. So it's whatever multiply I times whatever multiply I plus whatever multiply j times whatever multiply j plus whatever multiply k times whatever multiply k. Alright? So remember that. So it's 1 times half, which is just half plus. So this 1 times half plus 2y times square root of 3 over 2. It's 2y times square root of 3 over 2. Well, guess what? 2 would cancel 2 here now. It's going to be half plus square root of 3y. Half plus square root of 3y. Alright. Now let's say at the point 4, 0. Now at 4, 0, x is 0, y is 0. No, x is 4, y is 0. My. X is 4 and y is 0. Let me see now. We don't have any x, so we don't have to worry about that, only y. So the directional derivative in the direction of the vector of the function is half plus square root of 3 times 0, which is just half. Okay. So there we go. Here we have our directional derivative. Alright. If you got something different, it's either I made a mistake or you made a mistake or both. Alright. If you weren't able to do it or got something different and see that you made a mistake, then I want you to redo the question without looking back at my solution again. Alright, so that's it for now.